Okay, so now we're going to try to apply this a little bit. And the way that we can do that is by using integrals to help us find area. And remember, area is always positive. So if we want to find area, we need to make any negative parts negative. The opposite, sorry. So we're looking for this area down here and this area up here. So I just sketched a graph of this function, okay? You should know what that one looks like. So without a calculator, if we're trying to find the area, that should be equal to, now we can either say the integral from 1 to 0, or if you want the negative integral from 0 to 1, that's how we make that, x squared minus 1, sorry, that's how that we make that not negative. It's below the x-axis, so if we just integrate it, we'll get a negative number. All right, plus we want the amount from 1 to 3. Okay, so then you just do what we did the other day. You find the antiderivative. So 1/3 x cubed minus x evaluated from 0 to 1, and we got to make it negative when we're done. Plus the same thing, it's going to be 1/3 x cubed minus 1 evaluated from 1 to 3. All right, so evaluate. Negative, so we get, let's see, 1/3 minus 1 minus 0. Oh, that's a nice one. Plus, over here, 3 cubed times 1/3, that'll give us what? 9 minus, oh, I put a 1 there. Sorry, should have been x. 9 minus 3 minus 1 minus 1, which is 1/3. Man, I'm going way too fast here. I gotta slow down. All right, there we go. Let's see if we followed all that. Took the antiderivative, evaluated the first one from 0 to 1, evaluated the second one from 1 to 3. Okay, so then I have this negative here. Let's simplify. 1/3 minus 1. That'll be negative 2/3, right? And let's see, plus 6 minus 1/3 minus 1, which will be negative 2/3. So we get 2/3 plus 6 is 18/3 plus 2/3. So we get 22/3 for our area. All right, now with a calculator, you can go ahead and just type that in if you want to do that. Now, your calculator is going to make that bottom part negative. You don't want it to. So then there are two ways: you break it up, or what you can do on your calculator is say that you want to, the area is equal to, it's good to label what you're talking about, the integral or the accumulation from 0 to 3 of the absolute value of x squared minus 1. This way you don't have to worry about the negative regions because it's going to bump the graph up. Okay, so anything that's on the bottom is now going to be on the top, so it actually makes it look like this. It's just a little bit funkier equation, but now the area is up here. Okay, and you'll get the same amount. You should get 22/3. Great. All right, so there's we have two more problems like this. Find the area of the region bounded by the curves here. So it's good to sketch a graph. All right, so 2 over x, that's a hyperbola. So that's going to look something like this. All right, and we're only focused on the positive region right now, so I'm just going to worry about that. And we're going from an x value of 1 to an x value of e. So this is the area that we're talking about. All right, so we're going to do this without a calculator. We're going to find the area. So it's the net accumulation, or the integral from 1 to e of 2 over x minus 1 dx. Integrating this, we get 2 ln absolute value of x evaluated from 1 to e. So we get 2 ln e minus 2 ln 1. Okay. Oh man, I messed that one up big time. Ah, crud. All right. See, these are the mistakes you guys are going to do, right? So minus x. Oh, how could I forget that? All right, 1 to e. Good thing I noticed. So there we go. 2 ln e minus e minus 2 ln 1 minus 1. Oh man, I can't believe that big mistake. So 2 ln of e, that's just 2, minus e, minus ln of 1 is 0. So then plus 1. So I get 3 minus e. There we go. And we didn't have to worry about any negative regions. It's all above the graph. Same thing with a calculator here. You're going to say the area equals the integral from 1 to e of 2 over x minus 1 dx. Okay? And hopefully you know how to type that into your calculator. All right, so now this last one, we have a graph. And this one, so if you graph it, it kind of looks like this, if you graph it on a normal window. But because that 20, that negative 20 is on the top, I know that this is going to max out or really min out at negative 20. So this looks something like this. And we want the values from negative 1 to 1. Right, so we're talking about this area here. And now if we use our function in our calculator, it's going to give us the a negative value. And now there's one other thing added here. Use symmetry of the function to help you evaluate the integral. Well, this happens to be an even function, which means that it has y-axis symmetry. So if we just find this part, then we could just multiply it by 2 to get the other part. All right, so we're going to do that. The area is equal to, why is that green there? All right, the area is equal to, there's two ways we could set it up, and so we could say negative, or the opposite of negative 1 to 1, because it's on the bottom, we need it on the top of our function, negative 20 over x squared plus 1 dx. Or we're going to use the symmetry here. Instead of doing all of that, we're going to just go from, we'll say negative 2 times 0 to 1. Then our numbers might be a little bit easier too. So we have negative 20 times this function, which we recognize as the derivative of one of our inverse tangent functions, inverse trig functions. So again, I'm going to just keep simplifying a little bit. I'm going to pull that 20 out. Now I'm going to get 40 times the integral of x squared plus 1 dx. So I'll get 40 times inverse tangent of x evaluated from 1 to 0. So 40 times inverse tangent of 1 minus inverse tangent of 0. So where is tangent equal to 1? That's at pi over 4. And tangent's equal to 0 at 0. So I'm going to get 40 times pi over 4, or the exact value of 10 pi. Okay, and then you can check that. Go ahead on your calculator. All right, so the next part that I'm going to discuss, I think this is kind of neat, and you see a lot of this in the open-ended questions on the AP exam. So the second part of the fundamental theorem of calculus deals with equations like this, where you're going from a number to some variable, where you don't know what variable, and then they give you different upper bounds. All right, so let's see. If we look at f of t is on our graph here, and we're trying to do the antiderivative, working with an integral here, we're going to try to find areas of the region. We know that this fact is true. So since we're going to have to find areas of the region, and I see that that lower bounds is 2, I'm going to go ahead and just find all these areas, because it's going to save some time later on. So I'm going to write them in. If you don't understand how to get the area of that first triangle, or this trapezoid, or this trapezoid, or this one, just ask in class. All right, I can help you find those areas if you need to. So what we're doing here is we're saying we want, for the first one, to integrate from 2 to 2, okay, of f of t dt, sorry. You want to find the area of the region, the accumulation of the region from x equals 2 to x equals 2. Well, that gives us a big old whopping 0. There's no area. We didn't go anywhere. All right, this one, we're going to find the area from 2 to 9 of f of t dt. Okay, and so the area from 2 to 9 is just 120. That's the area under the curve for that part. Okay. 15, this one changes a little. I need to make this a little thinner, sorry. This one changes a little because now if we integrate from 2 to 15, right, f of t dt, now we're not really finding area per se. So this part is positive from 2 to 9. That's positive. But this part is going to be negative. All right, so to go from, we have to add 120 and then minus 50. So this integral is actually just going to be equal to 70. All right, let's try one more f of 18 here. Actually, that's one that I would like you to do. Find the integral from 2 to 18 of f of t dt and put that in your list. All right, and then the last one, f of 0, this one is neat because we're going from 2 to 0 of f of t dt. Now you have two ways of managing this. One way would be to rewrite it. You can switch them, and you could say negative the integral from 0 to 2, which is 20, so we get negative 20. Or you remember from a previous lesson, that if you go backwards, it's the opposite. So then anything above the x-axis would be negative. Either way, you get an answer of negative 20 for the last one. All right, we'll continue on later.